Hello there! We are to solve for this given linear system. We have 8x minus 3y equals 1 and 2x minus 3y equals 4. So we are given with this linear system. This is still linear system, or specifically known as the linear equations in two variables, for we have x and y variables and the exponents of x and y are both 1. And if you are to graph these two equations, they will form a line. Speaking of graph, the solution for this given linear system contains the intersection of those two lines that are represented by these equations. Now, if they don't intersect, then there's no solution for this, etc., etc. But that's just one method. Again, you can use the method for graphing in solving for the solution of this given linear system. We can also use substitution, but for this video, allow me to use elimination method. The method of elimination allows to eliminate one of the two variables to solve for the other. And once the one of the variables is solved, we're going to use that to solve for the variable that was eliminated first. We have here these equations. Let me try to copy these equations here. I have 8x minus 3y equals 1, and we also have 2x minus 3y equals 4. In the process of elimination method, we are to decide which variables we would like to remove first. Now, for our x variable, 8 is a multiple of 2, so we can remove x in that manner. We can just simply multiply the second equation, the entire second equation, by -4 so that we could remove x and solve for y. But of course, looking at our second coefficients, the y, you have -3y and -3y. They are almost the same. So instead of multiplying the second equation by -4, we can just do this. We can multiply the second equation by -1. Once we multiply the second equation by -1, what happens to the -3y of the second equation will become positive 3y. It will be the opposite of the -3y on our first equation, hence we can remove y. So it will look like this. 8x minus 3y is equal to 1. It's still like that. But the second equation, and take note that if you're multiplying a constant, all the terms inside in the equation you're multiplying for will have the multiplier of the constant. So the 2x becomes minus 2x. As mentioned, the minus 3y becomes plus 3y, and the 4 becomes minus 4. With this, we can see that the the second terms, or the coefficients of y, are of opposite, and when we add both equations, that is what will happen when we use the elimination method. We are going to add the equations. We can remove now this 2, leaving us with 8x minus 2x, or 8x plus -2x. I have 6x here, and for the constant 1 minus 4, so we have -3. In short, x, when we divide both sides by 6, we will get -1/2. Of course, fractions or other forms of rational numbers are also possible as part of the solution. So you don't need to be afraid of fractions. What you just need to do is, of course, be reminded of the properties and the operations involving fractions. Now, this is -1/2 for the value of x, because the solution, as mentioned earlier, is an intersection of the two lines. Hence, it's a point. So it should be a coordinate. So we already have x. We are going to use this x to solve for the value of y. Now, we can choose any of the two equations. But when we do that, we need to again be reminded of how fractions work. And I'm just going to show you the substitution on both equations, so that this is also a verification that this is really true. Because if this value of x, which is -1/2, satisfies only one of the two equations, that is, this is not yet the final answer. Let us try to use the first equation. I have here 8x minus 3y is equal to 1. To solve for y, let me substitute x. So 8 times negative 1 half minus 3y equals 1. Okay, so again, multiply fractions by integers. That's negative 4, because okay, again, you could you could cancel that out, right? So you'll have negative 4 minus 3y is equal to 1. Add both sides by 4 to remove to remove this negative here. So we'll have a value which is equal to negative 3y is equal to plus 1 plus 4, you have 5, and you will have the final result here for y, which is negative 5/3, as you are going to divide both sides by negative 3. Again, it's still a fraction, no need to worry. Now, we are also going to verify this in our given second form. If it satisfies this second equation, therefore, we will accept x as negative 1 half and the value of y is negative 5/3. But when you substitute the value of x to your second equation, the suggestion here is you are going to use the original equation, not the derivation after you multiply a certain constant, because there might be an error from the original to the new version with the constant as a new multiplier. And you could verify that when you substitute your value of x, or the first variable that you have solved, in the original equation, and if the value will not match the value presented earlier, then both solutions are incorrect. You just need to review your processes. So let's continue. The original equation is 2x minus 3y is equal to 4. So when we substitute 1 half or negative 1 half, you have 2 times negative 1 half minus 3y equals 4, right? Then you will have it here. When you multiply that, you have negative 1 minus 3y is equal to 4. Add both sides by 1. You will have negative 3y is equal to 4 plus 1, which is 5. You will have the same value for y, which is negative 5/3. With this, our solution, okay, our solution is the coordinate of the point of the Cartesian plane having x, which is negative 1 half, and y, which is negative 5/3. This is already the solution now. Okay, so this was made possible by the process of elimination and the application of these processes. Now, I would like to, if you don't like to hear the rest of the discussion, you may stop the video, but I would like to move further on the checking portion. This is also very essential for you as students, that you should be able to check whether your answers are correct or not by using the values of x and y that you have solved in both of your original equations. Let's try to use the first equation. 8x minus 3y must be 1. Let's try to substitute the values of x and y. 8 times negative 1 half minus 3 times negative 5/3 question mark 1. I'm using question mark because I need to make sure that both sides of the equations are the same. So you have it here just like that, as mentioned, negative 4, and here, okay, so 3, the negative, double negative property here. So you have plus 5 question mark 1. Even if it's too obvious, just simply continue and make sure that both sides of the equations are the same. 1 equals 1, check. And again, this solution must also satisfy the second, so that we could really say that this is the solution. But of course, let's use the original equation. You have 2x minus 3y is 4. So 2 times negative 1 half minus 3 times negative 5/3 question mark equal to 4. Again, just like that, negative 1 in here as well, and double negative property, so plus 5 question mark 4. You will have 4 equal to 4. See, our solution earlier is already the correct solution for this linear system. So in this case, we have fractions as part of our solution, but you don't need to worry, just simply review your processes involving fractions. Thank you very much for watching.